Okay, so this time we consider solution to non-exact equations. So if the partial derivative of m with respect to y is not equal to the partial derivative of n with respect to x, then we say that the equation m dx plus n dy is a non-exact equation. And if lambda is an integrating factor of this equation, then multiplying each term by lambda will make the equation exact. So our objective is to make or is to find an integrating factor that will make the equation exact. So the first one is by inspection. The ability to find the integrating factor of a non-exact equation will depend largely upon the recognition of some exact differentials. So here are some common exact differentials. So let's say x dy plus y dx, that can be simplified into derivative of the product of x and y. X dy minus y dx will be or will lead to derivative of y over x. So since we don't have x squared here, then we have to multiply by x squared as a correction factor. Or if you have x dy minus y dx over x squared, that is simply derivative of y over x. This exact differential is derivative of arc tangent of y over x. And for combination of x and y, power of x and y, you get the derivative of x raised to m, y raised to n. Okay, so let's solve this differential equation. Now you can verify that the equation is non-exact, which does not satisfy this property, or condition for exactness. So expanding the terms, we have yx cubed multiplied by dx, and then negative y to the 6 dx, negative x to the 4th dy, and then xy to the 5th dy. And then look for the terms that can be combined. Let's say the first and the third term, no? You can factor out x cubed here, and that gives you y dx minus x dy. And the second term, okay, and the fourth term can be combined. You can factor out y to the 5th, including the negative sign, will give you y dx plus x dy. So this is an exact differential of x over y, but you have to multiply by y squared. This one is derivative of xy. Now for the equation to be integrable, we have to eliminate y to the 5th here by multiplying by 1 over y to the 5th, and then multiplying by 1 over y to the 5th will give you x cubed over y cubed here, or x over y raised to the power 3. And then y to the 5th will cancel out here, so this is now integrable. This is u cubed, u to the power 3, so u to the power 3 du. So the integral of u cubed is u to the 4th over 4, or x over y to the 4th over 4. And then derivative of xy, integral of the derivative of xy is xy. Or simplifying the equation by multiplying the whole equation by 4 to the y, 4th no, will give you this equation: x to the 4th minus 4xy to the 5th equals c y to the fourth as your general solution. Okay, let's have another example. So again, this equation is not exact. No, you can verify that the partial derivative of m with respect to y, okay, is not equal to the partial derivative of n with respect to x. So we find an integrating factor by inspection. No? So this is non-exact. Okay, so expanding, we have yx cubed, no, e to the xy dx for the first term, and then for the second term, minus y squared dx, third term xy dy, fourth term x to the fourth e to the xy dy, and then we combine, of course, the one with exponential e to the xy. No, we can factor out x cubed and e to the xy. That will give you y dx plus x dy. And then for the second term, this one, and third term, the common factor is y. So negative y, so you get y dx minus x dy. And then this is exact differential, can be expressed or rewritten as derivative of xy. This one is quotient, no, but you have to multiply by y squared here. This is derivative of x over y. So multiply by y squared will give you y cubed. And then an integrating factor of 1 over x cubed, no, to eliminate x cubed here. So you get e to the xy derivative of xy. And then this is y cubed, x cubed. Okay, we try to express everything as a function of x over y. So this can be written as 1 over x cubed over y raised to the power 3. So it's like integrating e to the u du here, then integrating, this is v over v cubed or v raised to negative 3, tapos d, and then dv. Then integrating e to the u is e to the u, so e to the xy. Integral of v to the negative 3, so plus 1, negative 2 over negative 2. So you have x over y raised to negative 2 over negative 2. And then, simplifying, no, this will give you y squared over x squared. So we multiply by the whole equation, no, by 2x squared to eliminate the denominator, or to clear the equation with fractions by multiplying by 2x squared, no, and the resulting equation or simplified equation will be 2x squared e to the xy plus y squared equals c x squared as your general solution.